Hello everybody. Today we're going to go over a couple of basic definitions and theorems to review geometry. We might do a couple examples just in preparation for our next class. Okay, so as you can see, we're going to start with complementary and supplementary angles. It says that the definition of complementary angles is that their measure adds to 90 degrees, and the definition of supplementary angles is that their measure adds to 180 degrees. So let's go ahead and look at an example here. So we're going to look at an angle A that has a measure of 72 degrees. Okay, and then first we are going to find the complementary angle. Okay, and then for part B, we're going to find the supplementary angle. Okay, so here for the complementary angle, we're going to go ahead and use the fact that they should add to 90 degrees. So our angle 72 plus the unknown complementary angle x should add to 90 degrees. Okay, so we would go ahead and subtract 72 from both sides. Okay, and this would tell us that our complementary angle is 18 degrees. Okay, similar for the supplementary angle, we're going to say that our known angle 72 and our unknown supplementary angle y are going to add to 180 degrees. We would go ahead and subtract 72 from both sides. Okay, and that is going to leave us with 108 degrees. Okay, so that's the basics of finding complementary and supplementary angles. Okay, so let's move on to the definition of some different types of triangles that we are going to encounter. Okay, so we talked about in class last time that the measure of the three angles in a triangle add up to 180 degrees. Okay, and we're going to talk about first two types of triangles that just have to do with angle measure. So an acute triangle has all three angles less than 90 degrees, but an obtuse triangle has an angle whose measure is greater than 90 degrees. Now, we know that only one angle is going to have a measure greater than 90 degrees just because we know they add to 180. So there's no way to have two that are bigger than 90 and have all three of them add to 180. Okay. Now there's some classifications of triangles that have to do with side length. Okay. An equilateral triangle is a triangle whose all three sides have the same length. So you can see in this picture here that all three of the sides look like they're the same length. You will often see that indicated in diagrams with a line like this to show that all of the sides have the same length. Now, if all of these sides have the same length, that automatically means that all three of these angles also have the same measure. Okay, now we can see that a lot of times in diagrams that will be indicated with marking them with the same markings. Okay, so let's figure out what that angle is. Okay, now we know that all three of them are the same, right? So we can say that each of them has a measure of x degrees. Okay, and when we add all three of these up, we know that they're going to have a total of 180 degrees. Right, so we have 3x equals 180 degrees. So x, the measure of each of those angles, is going to be 60 degrees. Okay, so in every equilateral triangle, we know that all three of the angles are 60 degrees. Okay. Now, we can also have what's called an isosceles triangle. Now, in an isosceles triangle, two of the sides are the same length. So you can see in this image that this long side and this one here are the same length. Okay, now this means that the corresponding angles, right, the angle that corresponds to this side here, this first side, is this angle. Okay, and the angle that corresponds to this second side is that angle. Okay, so those two angles are going to be equal, and these two sides are going to have equal length. Okay. Now, one type of triangle that we already talked about in class is a right triangle. Okay, so remember that the right triangle is one who has a right angle. Okay, we know that means that one of the angles is 90 degrees, and you can see that indicated with this little square in the diagram. Okay, now the corresponding side to the right angle is the one that's is across from it. Okay, and we know that that's called the hypotenuse. Okay, the other two sides, okay, we've got this angle here that corresponds to this side. This is called a leg of a right triangle, and the smaller angle corresponds to this smaller size. That is the other leg. Okay, remember that the hypotenuse is always the longest side, because that 90-degree angle is the largest angle. Okay. Now there is a special type of right triangle. Okay. So this is the kind pictured right here. This is an isosceles right triangle. We do have that right angle in the corner here with our hypotenuse. Okay. And then we have our two legs. And in an isosceles right triangle, the two legs are the same length. So this side and this side have the same length. Okay, now that means that this angle here and this angle here have to have the same measure. Okay, now again, we can figure out what that measure is going to be. Okay, so let's take a second to figure that out. So when we look at these here, these are going to have the same measure. We're going to call that angle x. Okay, so we know that when we add these three angles up, x plus the 90-degree angle, right, the right angle here, that's going to be equal to 180. Okay, add my two like terms here, and then I'm going to solve for x. So I'm going to subtract 90 from both sides, and then divide both sides by 2. Okay, so that tells me that in an isosceles right triangle, both of these angles are 45 degrees. Okay, the legs are the same length, and of course that right angle is 90 degrees. Okay, we are also going to talk about this type of triangle in class and spend some time talking about the relationship between the lengths of the legs in this triangle, but I just wanted to introduce that style of triangle and talk about what the angle measures are going to be there.